All right, quick video forecast update for a potential snow day on Wednesday, January 25th. This is mostly focused on the central Ohio region, but we're going to start off with a zoomed out view of the large scale weather pattern. Then we'll zoom in, look at a couple different model solutions, what could potentially happen on Wednesday evening. And lastly, we'll talk about the different things that could actually throw a wrench in our snow day that could potentially lead to us being here at school on Wednesday morning. So first off, I'm going to highlight this massive trough that is over the western half of the United States, kind of centered in northwestern Arizona right now. So I have this big trough right here. Here's the center of the low, the upper level low right there. And you can also see the current trough. This is way up high in the atmosphere where we look for the jet stream. We can see this dip in the jet stream that caused our snow in central Ohio yesterday. We were receiving about 1 inch per hour snowfall rates on Sunday morning. So this particular storm, you can see, I want to highlight that the storm that we experienced yesterday was a positively tilted trough, which means that the trough axis, if you try to like draw a line right down the center of the trough, it's leaning forward or with the flow from west to east. So it's a positive tilt to this trough. It's going to be a big difference with our storm system that we see tomorrow. So usually positively tilted systems, we're not going to see rapid deepening of low pressure and we're not going to see as strong of a storm. If I advance our slides a little bit here, advance to getting into Tuesday evening and early Wednesday morning, we're going to watch the trough that's creating our storm for Wednesday morning start to take on a much different appearance. So this trough is now starting to look kind of neutrally tilted or straight up and down. And then by the time we get to Wednesday, really early Wednesday morning, if I draw our trough now, we see this kind of negative tilt where it's kind of tilted backwards. That is a sign of a rapidly strengthening storm system. Very, very strong system, deepening low pressure. That's going to have a huge impact on why this storm is going to be different from what we experienced on Sunday. Could also have a big impact on the possible failure modes for this storm producing a snow day. So why it might not produce a snow day. So taking a look now, let's actually go back and look at just the evolution of what this is going to do at the surface. So we just looked at the upper air pattern, the jet stream aloft. Let's look at the surface really quick. Look at the precipitation type. So we're looking at greens and yellows for rain, blue for snow, purple for the heaviest snow, and then some reds for freezing rain and purples for sleets. So here's our storm right here, forming, really starting to form over the panhandle of Texas, dipping down here. We're going to watch it go right up the Mississippi Valley here. And fast forwarding to about 5 a.m. on Wednesday, it looks like it's a lock, right? Snow day. We're getting snow, pretty heavy rates of snow at 5 a.m. That seems like all but a guarantee we're going to have a snow day. So we've got a rapidly deepening low here, just to kind of highlight the different things that are going on in this image. Let me go back here, just lost my place. We got a rapidly deepening low. And when you have a really strong storm system, we're going to have moisture being advected or transported on the right side of this storm. So we're going to see some thunderstorms down here in Mississippi and Alabama and eventually Georgia, maybe even up into Tennessee. And then we have a couple different things going on here. We've got kind of a cold conveyor dumping cold air in on the backside of the storm. So we're getting cold air being kind of pulled in at the upper levels from that direction, and then at the surface kind of coming in from this direction. We also have some cold air wrapping around the low like this, and some cold air might be coming in kind of in this direction like this, which is keeping the north and west side of the storm to the left of that line I just drew as all snow. And then to the right of that line, seeing a lot of rain and thunderstorms because that warm conveyor is kind of winning the battle. All right. So when we advance this, like right up to about school starting time, like 8 a.m., it looks like we're still all snow here, which would be, again, seems like a really good sign, right? Let's just look at a couple different models to compare what they're showing, so that one model run doesn't actually give us like a guarantee of what's going to happen. So we can look at a couple, and let's keep it right at that 5 a.m. because that's when we're really concerned, right? That's when your superintendents and principals are going to go out and make the call. So this was the model we were just looking at, GFS. Again, pretty reliable global model. It's NOAA's, the North American, or sorry, the American National Weather Service. This is their in-house model, and it's looking pretty good here. The rain's staying well south, or so it appears, of the Ohio River. So all good so far, right? Uh, Another model. Let's actually look at the NAM. I'll save the NAM because that was an interesting solution. Um, so RDPS, this Canadian model, it's not even really in range yet. The high res NAM still keeping the frozen precipitation, or the rain well south of the Ohio River. But if you look at the NAM here, this other model, North American Mesoscale model, you can see that there's a warm tongue of air right here that is creeping up the Scioto Valley right into central Ohio. And this is often, with these types of systems, this happens all the time. Sometimes it's under forecast by both models and meteorologists, but this model is picking it up, which raises a huge red flag for me to be a little bit concerned about it. I've shown soundings on videos before. This is a sounding of what the atmosphere looks like overhead. So the really important thing to look at this sounding. So this is like if you were to launch a weather balloon. This is the temperature as you go aloft, and the temperature is on a crooked axis. The really important thing to know is that that red line that I drew is the freezing line right there. So anything on this side of it is melted, and anything on the left side of it is freezing, basically. That's a really, really simplified version of that. So you can see that this model at the very lowest level, the red line is the air temperature. If we were to launch a weather balloon and measure the air temperature all the way up to 15 kilometers high in the atmosphere, well, there's this little tiny pocket right here near the surface, somewhere, I don't know, maybe around like, um, I don't know, half of a kilometer high in the atmosphere is what that looks like. And in that little area, the temperature is above freezing. So, um, and also that above freezing layer goes all the way down to the surface. You can see our surface temp is 33. So really similarly to what we saw on Sunday, where after the heaviest snow fell, the snow on the surface, especially road surfaces, started to melt really quickly. That could be the situation we're seeing here. So as the snow comes in on Sunday morning, it's going to be kind of a race, because as the snow first approaches our area, so if we look, going back one frame, closer to 2 a.m., as the snow is first approaching our area, you can see that our surface temperatures, according to this model, are 31 degrees. So we're right there on the line of freezing. And the entire column of air is to the left of that blue freezing level. So everything in this situation would be falling as snow, which is awesome. The only problem that I see now, though, is that green line shows us moisture. Now, one thing that we do have is this area right here is the big snowmaking region of the atmosphere. And that region is really deep in the atmosphere. So this is going to be a very efficient snowmaker, and the snow should fall pretty rapidly. But it's falling into a very dry column of air right here. So this green line shows us moisture in the atmosphere. So we're seeing some really good snow production falling into a very, very dry column of air. Okay, so this storm might at the very beginning struggle to produce high snowfall rates. By the time it is producing high snowfall rates, I'm a little concerned that it's going to be a little bit too warm in the lowest layers of the atmosphere, particularly our road surfaces. So just like on Sunday, where after the snow fell on road surfaces, it melted really rapidly because our surface temperatures went up, we're going to see a similar situation here. So the snow is coming in at about 1 a.m. and all the models are, some of them are a little bit drier, but they're all kind of in agreement sometime between like 1 and 5 a.m. The snow is going to come in. There might be a brief period where it falls really, really hard and starts to accumulate, but we also might see really rapid melting. I'm going to show one more thing, and then I'm going to call it because it's almost time to get to work and start teaching here on Monday. One last thing that I want to show is the snow depth, and we're going to go back and just take a look at how this model is forecasting snow depth. So we're here at 2.4 inches this morning in Columbus, which is a pretty accurate depiction of how much snow is on the ground right now. Going out into the future here, we're going to watch the snowfall start to fall here in Missouri, Southern Illinois, Indiana as the storm approaches. And then, bam, there we go, Wednesday night. So 2.8 inches. So we gain in about a 3-hour period between, this is actually forecasting it a little bit later now, in a 3-hour period, really approaching school start time between 5 and 7, we see that snowfall really increase. But remember, that's the same time where that warm air is starting to come in. And if you watch, that snow depth really by the afternoon starts to go back down. And then by the evening, we're back down to 1.1 inches. That's on grassy surfaces. I think by the afternoon, we might not have any snow on the road at all again if this model is accurate. Okay, so right now, I think that temperatures are really going to be the thing that could prevent us from getting a snow day on Wednesday. We're going to have to pay really, really close attention Tuesday night at the road temperatures and the air mass that is ahead of the storm system. If we can really get that a little bit colder, we'll have a chance. But right now, I'm not feeling too confident about it. The one thing that we do have on our side is the timing is pretty awesome. You can't ask for better timing for a snowstorm if you want a snow day. Not that I want a snow day because I want to be here teaching my kids, but if you're the type of person that wants a snow day, the timing's looking pretty good for us right now. So I will try to make another update this afternoon with the updated model forecasts as they come out. Still a lot of details to look at. I'd say like 40% chance right now. That's my final forecast as of 8:40 Monday morning. All right. Thank you for watching, and check back for an update later.